Here is a scenario that every new automation engineer goes through. You write a Selenium script, it works, and you feel great. Then you write another one, and another. Before long you have 20 Python files with no structure, no shared setup, and no way to run just the tests you care about. That is not a test suite. That is a pile of scripts. PyTest is what turns that pile into a professional framework. PyTest is the most widely used Python testing library in the world. It gives you a clean way to organize your tests, run them selectively, share setup code across files, and get readable reports when something fails. Almost every serious Python automation project uses it. And the best part? It works directly with your existing Selenium code. You do not have to rewrite anything. In this episode, you will learn how to install PyTest, how to structure your test project, how to write proper test functions, how to use fixtures for shared setup and teardown, and how to run only the tests you want using markers. By the end of this episode, your test code will look and behave like something you would actually see in a professional QA engineering team. This is not about adding complexity. It is about adding the right structure so that your test suite stays maintainable as it grows from 10 tests to 200. Installing PyTest is straightforward. Open your terminal and run pip install PyTest. That is the core library. You will also want pip install PyTest HTML for reports later, and if you are using Selenium, make sure WebDriver Manager is installed too. Now let us talk about project structure, because this is where beginners go wrong. Do not throw all your test files into one folder. Instead, create a dedicated tests directory at the root of your project. Inside that, you can have subfolders organized by feature or module, for example, test/auth, test/checkout, test/dashboard. Each test file should start with the prefix test underscore, for example test_login.py or test_search.py. PyTest discovers test files automatically using this naming convention. It scans your project, finds anything starting with test underscore, and runs those files. You do not need to import a test runner or register your files anywhere. Just name them correctly and PyTest finds them. At the root of your project, create a file called contest.py. This is where your shared fixtures live, and we will cover fixtures in just a moment. Having this structure from day one saves you from a massive refactoring headache later when your test suite grows from 10 tests to 200. In PyTest, a test is just a Python function whose name starts with test underscore. There is no class required, no special import, just a function. Here is the simplest possible test, def_test_login success. Inside, you write your Selenium code, and at the end you add an assert statement. PyTest runs the function, and if the assert passes, the test passes. If it raises any exception, the test fails. You get a clear output telling you which test failed, what the expected value was, and what the actual value was. That is one of PyTest's biggest advantages over plain Python scripts. The failure messages are human readable. When you run PyTest in your terminal from the project root, it discovers all your test files and runs every test function in them. You can also run a specific file with PyTest test/test_login.py, or run a single test with PyTest test/test_login.py : test_login_success. That double-colon syntax is how you target a specific test by name. You will use this constantly when debugging a single failing test and you do not want to wait for the entire suite to finish. Another useful flag is -x, which tells PyTest to stop after the first failure, great when you are working through a list of broken tests one at a time. Fixtures are the most powerful feature in PyTest and the one that separates beginners from experienced engineers. A fixture is a reusable piece of setup code that your test functions can request automatically. The most common use case in Selenium testing is the browser driver. Instead of creating and quitting a Chrome driver inside every single test function, which is repetitive and error-prone, you create one fixture that handles the driver lifecycle for all your tests. Here is how it works. You create a function, decorate it with @pytest.fixture, and inside it you yield the driver object. Everything before yield runs before the test. Everything after yield runs after the test, that is your teardown. Any test function that needs the driver just lists it as a parameter, and PyTest automatically runs the fixture and passes the result in. The test never has to create or close the driver itself. This is called dependency injection, and it makes your tests much cleaner and more reliable. Fixtures can also have a scope parameter function, class, module, or session. Function scope creates a fresh browser for every single test. Session scope creates one browser and shares it across the entire test run. For most cases, function scope is the right default. It keeps tests isolated and prevents state from leaking between them. You can also have fixtures that depend on other fixtures, which allows you to build layered setup logic without duplicating code. PyTest markers let you tag your tests so you can run specific groups on demand. This is essential once your test suite grows. You might have smoke tests that should run on every deployment, regression tests that run nightly, and slow integration tests that only run on the weekend. Markers let you separate all of these. You apply a marker by decorating your test function with @pytest.mark.your_ tag name. For example, @pytest.mark.smoke or @pytest.mark.regression. Then when you run PyTest, you use the -k flag to filter by marker. PyTest-k smoke runs only the tests marked as smoke. You can also combine markers, PyTest-k smoke or regression. Before using custom markers, register them in a pytest.ini or setup.cfg file so PyTest does not show warnings. Add a markers section and list each marker with a short description. PyTest also has built-in markers worth knowing. @pytest.mark.skip skips a test unconditionally. @pytest.mark.skip if skips it only when a condition is true, useful for skipping tests that require a specific environment. @pytest.mark.xfail marks a test as expected to fail, which is useful when you know about a known bug and you want to track it without breaking your CI pipeline. Together, fixtures and markers give you the control you need to run a large test suite efficiently. Let us recap what you learned today. PyTest is the professional standard for Python test automation. Your project should have a dedicated tests folder with test_prefixed files and a contest.py for shared fixtures. Test functions are plain Python functions starting with test_, no classes or boilerplate needed. Fixtures handle driver setup and teardown automatically, keeping your tests clean and isolated. And markers let you group and filter tests so you run exactly what you need, when you need it. If you have been writing your Selenium tests as standalone scripts, switching to PyTest will immediately make your code more organized, more reusable, and more professional. In the next episode, we are going deeper into test structure with the page object model. POM is the design pattern that makes large test suites maintainable. When your app changes, and it will, POM means you update one file instead of 20. That is episode 15, and it builds directly on the PyTest foundation you just built. Subscribe to QA Career Lab for daily episodes. Hit the like button if you are working through the QA Automation Bootcamp series. Every episode in this series stacks on the last one, so if you are finding value, stick with it. By episode 22 you will have a complete, professional automation framework built from scratch. I will see you in the next one.